Right, today we continue the descending of the projectile motion. Descending of projectile motion means when you project, it's not upwards, will be downwards. Let's say you have a scenario, right? The projector is downward, the projectile motion, and the initial velocity is 5, and the range that travel is hit on the ground will be 6 meters, and the height that you projected will be 10 meters. So if you want to apply the projectile motion equation directly in order to find the values that require, it's okay, but you must be very familiar, right? So recall the last week, no last week, yeah, correct. Recall last week question. If you have item projectile, okay, downwards, you need to change the G to positive. So when you do this, you will have a trajectory equation y equal to x tangent theta plus gx squared 2u squared secant square theta. Okay, so if you refer to your formula booklet will similar like that lah. The formula booklet will be in negative and in cos theta, so it's no problem. You just change accordingly. So refer to the case just now. If you want to find the theta, okay, you can compare this equation to the you just sub the value inside here first. 10 6 tangent theta, okay. And you have plus 10, the range will be 6 square, right, and 2 times 5 square, and in the second, if you put a change to tangent, will be 1 plus tangent square theta. So let's say the question asks you to find theta. So if you simplify this equation, will be have 7.2 tangent theta plus tangent theta minus 2.8 equal to 0. So sometimes the question may give you this directly and ask you to find certain values, right? So you should able to compare this to the original trajectory values. Okay, once you have this actually is a quadratic equation. So if you want to solve, you have to show how to solve, and you should get tangent theta equal to 1/3 and tangent theta equal to negative 7/6, right? So question, if ask you the theta, you should choose the positive one. If you choose the negative one, be more than 90 degrees already, so projected backwards already. So your answer should be the positive, this one. So if you solve it, you should get a theta is equal to 18.4 degrees. Right. So this is the angle for your projectile motion at the initial situation. Okay, so this is the way when you apply the trajectory equation directly, okay, in order to find the theta. There are the situation you may need to find the any unknown that in the trajectory equations. Okay, so actually, if you don't want to use the trajectory equation, you also can derive from the beginning, but maybe you will take longer time. So depends on you what should you do. Okay, so we go to question 5. See how to apply the equation. Okay, question 5. A ball is thrown from the top of the building of height 20 meters. The ball is thrown such that the initial speed is u, and the angle of depression and the throw is 30 degrees. A. Find the horizontal distance traveled in terms of u. Okay, so if we have y equal to x tangent theta, the trajectory equation, and this one is depression, so I change to positive directly, right, and secant square theta. So you sub all the value inside, you know that the height is 20 meters, and you have x square root 3 over 3 tangent theta, tangent 30, and plus 20x square okay over 3u square. Okay, so for this situation, the second theta you can directly change because you have the theta already. Okay, you can change directly. So in this situation, then you can change to a quadratic equation 20x square plus square root 3 u square x minus 60 u square equal to 0. And the question asks you find the horizontal distance travel in terms of u. So x must be in terms of u. So your u will be, your x will be equal to 1 over 40 multiply square root 3 then minus u square plus u square 1600 plus u square meter. Okay, so this is the x in terms of u. So now question asks you the horizontal distance when u equal to 5. When u equal to 5, then you sub the u inside. So you should get, when you sub the u inside, you should get x equal to 7.65 meter. So this is one of the application of the trajectory equation. You can directly use it and to calculate certain unknown that you want to find. Okay. Okay, then other situation, the question might give you something y in terms of x. Let's say y in terms of 0.5x minus 0.01x squared. Okay, so the question may say the particle follows a parabolic path y in terms of x, something like that. Actually this, if you see this, actually this is the trajectory equation that already simplified from the original general equation. So now you compare to the original general one, x equals x tangent theta minus gx square 2u square secant square theta. Okay, so now you can compare the term in x compared to term in x. Term in x square, then you compare to term in x square. So now we can extract something out. From here, you know tangent theta is equal to 0.5. And you know 0.01 is equal to g over 2u square multiply secant square theta. So now you have two things that actually you can find the values that you want. So now if you proceed to find the value, you know that tangent theta is equal to 0.5. And we know that 10 over 2u square secant square theta is equal to 0.01. Okay, so if you want to find secant square theta, you can derive from here, right? And from here, you know theta is equal to 26.57. This is not exact value. If you want exact value, you should use the triangle, right? Use a triangle, Taylor by Nicholas. Okay, so you know that secant theta is equal to 1 over cos theta. So you find the cos theta first, then sub inside the equation below, right? So if you have the exact value, you should be able to find the answer. Okay, so you were able to find that if the question asks you to find u, when you find the cos theta, you put it back here, you will find u equals to 20 meter per second. Right, so this is one of the example that you can apply. They give you a certain path equation, then you just compare to the trajectory equation. Right, so now we proceed to question 6. Question 6, a projectile follows a path of y equal to 0.3 x minus 0.1 x square. Right, find the initial speed and the angle elevation of the particle. So that this is the equation given. You can compare to the trajectory equation. tangent theta will be equal to 0.3. And you know that g over 2u squared secant square theta is equal to 0.1. Once you have these two, and you can solve it. As I say, you can use the exact value from here and sub inside here. Okay, so from here you should able to find theta equal to 16.7 and u equal to 7.38. Okay, so this is application of the trajectory equation. And question 7. Question 7. A particle is projected from the top of the tower is 50 meter tall. The initial speed is 25 and the angle depression is 10, so projected downwards. Find the height of the particle above the ground when the downward angle of direction is 30 degrees. Okay. For this question, you have many ways to do it. I will give you some way that different a bit to the normal way. So you know that the item projected in this way. You know that the angle. You want to find the angle when 30 degrees. So here is Vx, here is Vy, here is the V at the particular moment. Okay, so you know that tangent theta is equal to Vy over Vx. So that you can change to Vy equal to square root 3 over 3 Vx. Right, so we know that for vertical motion we have 25 sine 10 plus gt, but we have a Vx is equal to 25 cos 10. Okay, so use the relationship just now. You have 25 sine 10 plus gt is equal to just now square root 3 over 3 25 cos 10. Right, so here the formula come from here and the values come from here, this one. Okay, so from here you were able to find the t directly. So the t will be equal to 0.9873 second. So and question asks you find the height above the ground, so you can sub the y equal to 25 t sine 10. So the vertical displacement that at the particular moment you sub inside, you will get y equal to 9.1603. So they ask you the vertical distance from the ground, so you need to use 50 minus 1603. So the answer will be 40.8 from the ground. Okay, so this is one of the application of the using the comparison of the Vx over Vy. So in this chapter, actually the general equation is very simple. Just see how you go and apply. There are the situations when you use the certain way to calculate, the step will be shorter. There's no need to do so many substitution. Okay, but I'm not asking you to do the memorize of the equation. Just the methods need to use different way to do it. Maybe will be faster, maybe better. Okay. I'm sorry today, a little bit cough and flu. No issue. Anyway, so this is for question 7. Okay, we proceed to question the last question, question 8. Okay, question 8. This is the the typical type of the exam question, a small stone is projected from the point O with a horizontal ground with a speed v and the angle theta above the horizontal and the upwards vertical displacement of the particle from O and time second after projection are x and y respectively. The equation of the stone trajectory is y equal to 0.7x minus 0.02 x squared, where x, y are in meters. 5. Okay, A, the radius of theta and v. B, the distance of O from the point where the stone hits the ground, range. And C, the greatest height reached by the stone, the maximum height. Great. So for this question, when you see the equation y equal to 0.75x minus 0.02x squared, so means most probably they will ask you to compare to the original trajectory equation already. So this one projected upwards, so you compare to this tangent theta minus gx squared 2v squared secant squared theta. Okay, minus projected upward minus. So you can direct compare. But for if you don't want to compare, you need to derive from the original equation, then will take longer time. Okay, so if direct compare will be faster. So for this question, you can compare now. When you compare, you know tangent theta is equal to 3/4, 0.75. And so that you know that theta is equal to 36.9 directly already. Will be saved a lot of time. And you know that g/2v squared secant squared theta is equal to 0.02. And you need to find the cos theta from the tangent theta. Use the triangle bidiculars will be better because you will get the exact value. So here you will get cos theta equal to 4/5 from the bidiculars. So you can start inside the secant square theta, and in order to find the v. So your v will be equal to 25 square root 10/4. So about 19.8 meter per second. Okay. B. The distance from O of the point where the stone hits the ground, and you have the trajectory equation already given. So y equal to 0.75 x 0.02. The distance from O to hits on the ground, you know that at when the thing hits on the ground, y equal to 0, right? So you have 0.5 x 0.02 square. So solve it, you will have x equal to 0 and x equal to 37.5 meter. So your answer will be 37.5 meter, the range. And last one, C, the greatest height reached by the stone. Okay, so you know that the range, the total horizontal displacement is 37.5. So at the maximum height will be at the center point, the x will be 37.5/2, so 18.75. So if you want to find the maximum height, y will be equal to 0. Just submit back to the original equation. Just submit the original equation, and you will get the maximum height is 7.03 meter. So this is the things that you will use the trajectory equation directly. Okay, so no any restriction. Depends on case that you need to use. So don't memorize. Try to use different methods to calculate the question. Which one will be faster to you will be better. No any fixed things that you need to use. But when you see the question give you a trajectory, a quadratic equation, then most probably can be say 100% you need to use the trajectory equation to compare already. Don't go and use the derive from the beginning anymore. Okay, so this is for the last questions. So we close this chapter 1 projectile motion for further mechanics. I will post one question for you, okay, to solve as an assignment. So tomorrow we will go through a simple trial runs. So no any homework tomorrow. Just simple trial run for 1 or 2 questions. And once you're done, I will set a timing for you. 10 a.m. we start. So you should stand by 9:50. You should stand by 9:50, and 10 a.m. we start. I'll let you to do one or two questions, and you just do it instantly and submit as PDF to me. Okay. So today I will only post one assignment for you. All right. Thank you.